Hello, these notes will be following Modern Introductory Analysis by Dolciani, Bachenbach, Denelli, Jurgensen, and Wooten. And these will be the notes of the first section of the first chapter. So the first section is about logical statements and sets. First off, we have a set. Make those lowercase. We have a set. What a set is, it's like a collection of objects, which in math we call elements. And we tend to denote it with a capital letter. An example of a set would be, we could say, the set E equals 1, 3, 5, 7, and so on, up to infinity. Obviously, this would be the set of all the positive odd numbers. However, when we describe a set like this, where we list each unit and also the ellipses to help us see that goes out to infinity, we call this specifying by roster. We could also just straight up write out the set of all positive odd numbers, and that would be specifying by written description. And if we want to be more like formal and mathematical in it and showing the way the set is constructed, we could also say E equals the set of all x such that, which is what the colon indicates, x is equal to 2n plus 1, where where n is a positive whole. And this would be specifying by set builder, as we show the way that the set itself was built or constructed. Next up, we have different notations that we could use. So using the same set as before, we have E is equals 1, 3, 5, 7, ... One thing that we want to be able to say is a number part of this set, or is any object part of the set, or any element part of the set? And the way we denote that is by saying some number, we'll just use this because I'm assuming you're working with number, is a member, which is what this symbol means right here. It's like epsilon. Or it could also be or not a member of set E. So a number like, say, 3 would be a member of set E, but some even number like 6 would not be a member of set E. Additionally, you have the symbol for a subset. So we could say we have this random set of just a bunch of stuff in it, and we could say that's either a subset or not a subset of E. So the set 1, 3, 5 is because, all the elements 1, 3, 5 that are in this set, they make up a small set that's contained within this. We could also have 997. That's also, these are all odd numbers. They would all fall within here. However, like the set 1, 2, 3 would not be in set E. This is because 2 is an even number. It's not part of E, which means you cannot create a set from E that contains 2. On top of that, there are 2 different types of subsets. You have a proper and improper. A proper subset means that you would be something like what we just listed. 1, 3, 5, or actually no, 1, 3, 5, just that. And the reason it's called proper is because there's other members of set E. There's other members of set E that are not contained within this subset. However, if we were working with another set, let's call it A, you said A equals the set 1, 2, and then we said B equals also 1, 2. B would be a subset of A because B, all the elements in B can also be found in A. However, it's improper because there are no other elements inside of A that you cannot find in B, which also leads to a theorem that states if A equals B, then B is a subset of A, and A is a subset of B. Both improper, by the way. And the last thing on subsets specifically is that if you have this symbol, this means the empty set, it would be equal to just this. There's nothing in it. This is a subset. This is a subset of any set. This is because every single set, you could take nothing out of E and create this, and you could throw the nothing back in and nothing would change. No pun intended. But you could find the empty set within any set. However, it is not usually going to be a member because there's no set in here. But if we had, let's say, set F that was equal to 1, the empty set, and 2, then yes, the empty set would be an element of the set, but usually it's just going to be a subset of the set. Then there are 5 important sets to know. There's a few more, but the ones that need to be able to be quickly referenced in this course are these 5. N stands for a set of all naturals, which is 1, 2, 3, and so on. It's also called the counting numbers. You have W, which is a set of whole numbers, if I can spell, which is the only difference is the natural numbers, but you also have 0 in there. The set of all integers would be the all the whole numbers and their negative equivalent. So you would have like -1, -1, 0, 1, so on, both directions. Q, those are the rationals, which are any number that can be specified as a fraction. So we could, a way you could describe it, because there's no way you can really list out. I mean, you could have the example 1/2, 1/3, 997 over 15. Or you could explain it in a more concise and kind of more accurate definition, which would be the set of all x over y, such that x and y are both members of, remember that symbol from earlier, the integers. And y can't be 0 because you can't divide by 0, that breaks math, and no one's happy. And then the reals, we would just say, way this to be described for now is just all non-complex numbers. Because for now, that's just the most concise way to say it. I think that would be all the notes for section 1 of chapter 1. Goodbye.